Have you ever wondered how computers talk to each other? That's how. But how can you communicate and store such amount of different data if you only know 2 words? In this video series, we learn about the genius solutions that make this possible. Hi, I'm Noah, biology grad turned software engineering student, and I'm here to make tech feel a little less intimidating for both of us. In this video, we'll dive right to the core of it all, to the bits and bytes. Let's start with something foundational. When we talk about a computer processing information, we really talk about a pretty simple idea. Everything in a computer comes down to only 2 states. Not an abundance of states, only 2. Think of it like electricity flowing or not, charge present or absent, or switch flip on or off. In tech terms, this is called binary information processing, which would be displayed for us as a row of zeros and ones. Those build a foundation for everything a computer does. Let's get down to the bits and bytes. A bit is either a 0 or a 1. And because a single 0 or 1 isn't enough for us to represent numbers, letters, or symbols, we need more than that. And that's why we create patterns of bits. And the most common pattern of bits is called a byte, consisting of 8 bits. And those 8 bits give us 256 different patterns we could use for numbers, symbols, or letters. For example, that's how A, the letter A, is represented in ASCII. We will discuss what ASCII is in a different video. Back to the bits and bytes, because computers don't stop at bytes. Machine words are what your central processing unit really uses, or really works with. And a machine word consists of multiple bytes, 2, 4, or 8, for example, depending on the system you're using. And my biology-loving brain pictures this hierarchy like this. A bit is like a cell. It's the smallest unit that does something. And a byte is like tissue. It consists of multiple bits, like tissue consists of multiple cells. And a machine word is like an organ, consisting of multiple bytes, like an organ is consisting of multiple tissues. And the more bytes it has, like an organ, the more complex it can get, and the more complex work it can do. That's because it can handle more complex data in one step. Let's have a final look at one special bit. This one helps us to know whether or not one bit flipped during transmission or storage. It's called the checkbit or parity bit. Unfortunately, bits can flip, means they get corrupted, and this can happen, for example, due to high heat or cosmic rays. Now, how does our checkbit help? In our example, we want to send 7 bits of data. And we add another one, our checkbit. It's the 8th one. And this one we set so that the total number of ones is odd. This is called the odd parity. Now, if we send the data and the new computer receives it, it recalculates the parity. And then, if the parity isn't odd anymore, it knows, something happened. So our checkbit doesn't fix anything, but it helps to alert our system. And our system now knows something went wrong, we need to take action. If you want to take further action, check out my next video about the conversion between the binary, the decimal, and the hexadecimal number systems. Happy learning!